Good day, students of our great S.Adebayo A Plus Model School, Osun State, Nigeria. You're welcome to this class. My name is Taylor Samson Adeshino, and I will be taking you on basic science. Today, we'll be talking about a topic called force. Force. We'll be talking about force. And under this topic, we'll be discussing the meaning and types of force. The meaning and types of force that we have. Or let me say the meaning and types of forces that we have. Before we move forward, we have to know what force really means. What force really means. Force is any action that moves an object or alters its uniform motion in a given direction. That means we are saying force is something that causes an object to move. That means if you put an object in a place, if there is no force applied, that object will not move from that place till eternity. It will just be at that one place. So force is any action that moves an object or alters a uniform motion in a given direction. That means it must have a direction. It's a given direction. If you put a ball at the center of a field, you have to apply a force on that ball before it can move, and it moves in a what? In a uniform motion in a given direction. We can also say force is the product of mass of the object and its acceleration. That means the mass of that object and the rate at which that object is moving, which is acceleration. So the product, that means we can say force is the product of mass of an object and its acceleration. That means force equals to mass times acceleration. Now, there are some special things about force that we need to know. This one, the greater the mass of an object or the object, the greater the force required to move it. Yeah, that means if you are the force that you applied in moving a metal ball is different from the force that you applied in moving a just ordinary leather ball. The force, I repeat again, the force you apply in moving a metal ball is different from the force that you applied in moving a what? A leather ball. Or let me just use it as an example again. The force you applied in carrying your locker on your head is different from the force that you apply in carrying your book, just ordinary your book. That means the force that you apply when you are carrying a locker is higher than the force that you apply when you are carrying your ordinary book. The reason is that your locker has a greater mass than your book. Another example of force are pull, push, tension forces, and frictional force between surfaces. Pull, push, tension forces, and frictional force between surfaces. And the unit of force is Newton. That means when you want to calculate your force, the unit you use is what? Newton. Force is measured in Newton. Now, this is the mathematical expression of force. F, it is given as F is equal to mass times acceleration, which F is equal to ma, where m is equal to mass, and as a is acceleration due to gravity. We'll still talk about acceleration due to gravity, or we'll talk about gravity later in this topic. Now, let's go to types of forces. Types of forces. We have two types of forces. There are two types of forces, and we have it as contact force and not contact force. Contact force and non-contact force. Contact force and non-contact force, or force field. Now let's talk about contact force. These are force or forces whose sources are in contact with the body to which they are applied. That means for a contact force to happen, the force must come in contact with the body in which the body wants to exert the force. This occurs between two bodies making contact with each other. Okay, let me give an example. If you put a leather ball at the middle of a field, you need someone to come in contact with that leather ball before that leather ball can move. That means you need an object or someone to exert a force on that leather balls before that leather balls are moved. This type of force is called contact force. That means it involves two bodies, you yourself or the object that is coming in contact with the leather ball. And the contact can be direct or indirect. The contact can be direct or indirect. Example of direct contact force are push and friction. Push. When you want to open a door, you either pull or push. So when you push forward or you pull towards yourself. When you push forward, that means you are exerting a force. Or when you pull towards yourself, you are exerting a force. That is an example of what? Sorry. An example of direct contact is when you push, while indirect contact forces are when you pull and tension. When you pull and tension. Example, when your car has a fault and you have to push, you exert a force to push your car. That means pushing a car. Or when you want to pull, maybe you sit down at your table or your locker is far away from you, you want to draw that locker closer to you, you pull. You pull the table towards you. You pull a table towards you. So that's an example of the contact and the direct or indirect contact force. Now let's talk about non-contact force. Now we've said that the contact force involves two bodies. There must be two bodies and the two bodies must come in contact. Now let's talk about non-contact force or force field. Force field is a force whose source does not require contact with the object to which it is applied. Yes, you don't need the object to even come in contact with each other before the force is being exerted. It occurs between two bodies or objects are separated by space. The body does not necessarily need to come in contact before the force is exerted on it. Example, a very good example of this is magnetic force. If you place a magnet at the middle of iron, the magnet exerts a kind of field that any iron or any metal in the area of that field will draw closer or be sticked to the magnet without even coming in contact with it. And this is an example of what this field is called magnetic field. We're still going to talk about that later. So the type of force that comes in contact, you can experiment it at home. Just look for a bar of magnet, look for a pin, put a pin in a distance from that magnet. You will notice that when you place the magnet closer to the field without coming in contact, the force draws the pin towards the magnet and they stick together. So that is an example of non-contact force or gravitational force. This is the force that happens when you throw something up. You notice that no matter how you throw something up, it always comes down. There is a force pulling the object down to the earth surface. It is called gravitational force. When you jump up, you notice that you come down. There is a force that is pulling you back towards the earth, and that force is called gravitational force. So this is a diagram of magnetic and magnetic field. All these things you're seeing around the object you are seeing is the magnet. You can see the south pole and the north pole, and you can see the kind of field exerted around the magnetic pole. And you can see that this magnetic pole, the edge of the pole is the one that has the highest magnetic attraction, because that's where the force is most concentrated. And you can see that there is a space. That means all those metals beside that field has been drawn to the magnet. So this is an example of what? Non-contact force. They don't need to come in contact with the magnet before the force is being exerted. So let's talk about magnetic field. A magnetic field gives a magnet its pulling power, called magnetism. That means if you place a magnet bar and you place a pin, if the pin is not in the region of the magnetic field of that magnet, the region of the field of that magnet, the the force will not be exerted on the pin. But when you now shift the magnet close to the pin, you will notice that suddenly the magnet will just attract the pin. That means the pin is now in the field, the force field of that magnet, and that's why it's attracted to itself. You can see the picture shows the fragment of metal sticking to the end of the magnet. I'm talking about this picture. You can see the edge of those magnets, the metal sticking to it, because that's where the force field is at the peak. Now, the magnetic field of this magnet is strongest at the head. I think I've said that. You can see at the head, that's where the magnetic force is the strongest. You can notice that. So now let's talk about magnetic force. Magnetic force. There is a force that exists around the magnet. I think I explained that earlier. The force that exists around the magnet. If you pull a magnet down, around that magnet there is a force around it. You cannot see it with your physical eyes. The only way you can know that there is a force around that magnet is when you put a metal near that magnet. You will see the magnet drawing the metal close to itself. That's when you know that there is a force around that magnet. Objects like iron, pin, and nail are attracted by the magnetic force if brought within the magnetic field. I've explained that earlier, that if the iron is brought near the magnetic field, it will be attracted to the magnet. So that's that about magnetic force. Now let's talk about a more interesting thing, which is gravitational force. Gravitational force. This is the force with which the earth pulls all objects towards its center. It is also called force of gravity. You should have been wondering that why will I throw something up and it will come down? What is bringing that thing down towards back to the earth? When I jump up, why don't I just continue to be going up without coming down? There is a force exerted on the earth which is called gravitational force, and this force is responsible for pulling all objects towards the center of the earth, towards the center of the earth. And another amazing thing is that this force depends on the mass. The rate at which this force works depends on the mass of the object. Now, for example, if you go to a story building, you hold a stone and you hold a feather. Let me say maybe a feather, a bird's feather, and you release both the stone and the feather at the same time. You will notice that the stone gets to the earth's surface before the feather. Why? The only thing that happens here is because the mass of the stone is heavier than the mass, or sorry, let me use weight or mass of the stone is heavier than the mass of the feather. So the higher the mass, the higher the gravitational pull. The higher the mass, the higher the gravitational pull. While the lower the mass, the lower the gravitational pull. And that's why you see that the stone gets to the earth's surface before the feather. So if a piece of stone and the feather are allowed to fall at the same time, the stone reaches the ground first. This means that the rate of force depend on the body or weight or mass of an object. I think you understand that perfectly well. Now let's talk about electric force. Electric force. This is a force that exists between two electric charges. Your wire at home. The force that existed between your electric charges at home is called what? Electric charge. And here, unlike charges attract each other while like charges repel each other. That means if you are bringing positive and positive together, they repel. And if you are bringing negative or negative together, they repel. But if you are bringing positive charges and negative charges together, they do what? They attract. So if you bring like charges together, they repel. But if you bring unlike charges together, they what? They attract. A repulsive electric force exists between either two positive charges or what? Two negative charges. That's what it repulses. That means it repels. Electric force exists between either two positive charges or two negative charges. Now let's talk about the difference between gravitational force and magnetic force. I believe all of us know the meaning of gravitational force and we know the meaning of magnetic force. If you find it difficult to understand, you can still scroll back or you go back and check my explanation. Now, let's check. Gravitational force. It is the pull exerted by the earth on objects. I think I've explained that. A force that is exerted by an object, by the earth on an object. While under magnetic force is the property of some substance to attract iron or steel object towards itself. Like the pin that I said is within the region of the magnetic field, it tends to attract it to itself. Number two, the direction of the force is always downward the center of the earth. Yes, it's always downward. It doesn't go up. When you throw something up, the force brings it down to the earth. When you throw something from up, it brings it down to the earth. Then under magnetic force, the direction of the force is towards the magnet. The direction of the force is towards the magnet. That means it pulls towards the magnet. If you put a magnet closer to a pin, the direction is always towards the magnet. The strength of the force is weak. Yes, it is always weak. Where that of magnetic force, the strength of the magnetic force is very strong. We're still talking about the difference between magnetic force and magnetic force and gravitational force. Now, under gravitational force cannot pass through substances like wood, metal, or glass, while in magnetic force can easily pass through substances like wood or glass. Gravitational force gives object its weight. Yes, it gives object its what? Its weight. Why magnetic force cannot give weight to object. It cannot give weight to object. Gravitational force enables fruit to fall from trees. And maybe there is no gravitational force. All the fruit that falls when it's ripe on the tree will just be going up. It will not come down. But because of the work of the gravitational force, it pulls this down towards there. And that's why when you go under your tree, maybe under your mango tree, you see mango fruits on the ground that you can just pick up and eat. But maybe there is no gravitational force. That means the fruits will just be going up. It will not come down. But under magnetic force cannot fall fruit from tree. You cannot put a magnet under a tree and you expect that magnet to draw the fruit on that tree towards itself. Now, let's talk about uses of force. Uses of force. It is needed to make objects move. Without force, that means all of us will just be in one place. Any object will not just move, no matter how, if there is no force. That means when you sit down on your bed or you sit down in the class, you will not be able to stand up. You will not be able to move to anywhere because there is no force to make you move. It prevents car wheels from slipping on a tarred road when moving on it. Yes, the grip between the tire of your car and the tar road, there is a force that grips the tire and fan. That's why when you are moving a car, you do not see that the car will not be slippery. So is force is responsible for this. It makes it possible for the car to stop or slow down when the brakes are being applied. Yeah. If there is no force, that means when you are driving a car, when you want to apply a brake, the car will not stop. Imagine how many accidents we will have been having and there is no force. So one of the uses of force, it allows our brake to slow down the car or stop a car when it's being applied. Another uses of force is friction between the sole of our feet and the ground makes it possible for us to walk without slipping. That is, if there is no force, when you try to walk, you just be falling down because there will not be force between the earth surface and your slippers. And it will be very, very slippery. Magnetic force is used by watch repairers to pick tiny iron materials like pin and screws. Yes, when watch repairers want to use wants to repair a watch, maybe they need to pick up a pin. They just need to put a magnet close to the watch. If the pin is within the region of the magnet, it attracts the pin towards itself. Even the tailors, the fashion designers also use it. Maybe they're looking for a pin or an object that is of metal and it falls down. Maybe when they are working, just have to pull the magnet around the area you suspected. Before you know it will attract the pin or the metal that you're looking for towards itself. So it's also one of the uses of force. Magnetic force is applied to separate iron dust from solid non-magnetic substances like sulfur and sand. I think I just explained that. So when you are looking for maybe a metal in a sand, all you need is just to bring your magnet to close to the sand and make sure it is within the magnetic field. It will find, or it will seek out the metal out from the dust or the sand. With this, I believe you perfectly understand the meaning of force and the uses of force. At the end of this lesson, I believe you must have understand all these things. You must have understand what is a force field. You must have understand that you should be able to define or explain what a force field means. You should be able to explain with example the two types of force field that we have. We have the two types of force field. You should be able to explain that. And I will be combining your evaluation with your assignment, and it's to be submitted Saturday this week. So your assignment starts from your evaluation. Your number one assignment is what is a force field. Number two is explain with example the two types of force field that we have. Number three assignment is state the formula used in calculating gravitational force. I know this has not been taught in the lesson, but you have to read ahead because this topic is what we'll be doing in our next class. So I need you to read ahead and state the formula used in calculating your gravitational force. And next one is mention the unit of work. Mention the unit of work, or better still, list the unit of work, or write down the unit of work. With this, we have come to the end of the class, and I believe you understand. If you have any question to ask, you can always reach me on my WhatsApp page and ask your question. I will be available at any time you need to ask your questions. Thanks for listening. Thanks for the class, and I wish you best of luck. Thank you.